I turn this around here, there is also a car at some point.
A car?
Yes, yeah, you can see that there.
Yeah.
So in real life, this is what we did. When we went down to ASCO, south of Stockholm, we have a partner in a company called MMT. They do underwater surveys. So they had a Mini Cooper to spare, so they dropped it in the water. And we did a waypoint survey to find it. Like we went around in a spiral and tried to find it. And we decided to first test bed it in the simulation environment. So we had bathymetric data for ASCO. So we overlaid that bathymetry to create like a world down here. So there is like the sea floor. It looks very similar to the actual terrain. And on top of that, we added a 3D model of the car. And one of our colleagues from the computer science department, he made a very simple algorithm to find it from the image, like to find the color yellow and shape of a car, and then that works. And on top of that, all the subsystems of the robot are also modeled quite accurately inside here. The problem is, like I told you before, the physics are not always perfect in this environment, but the idea is to get all the connections properly. So if you have the controllers, if you have the planning, if you have the perception, to make sure that they're all talking to each other in the right way, we could test that very well here so that we could rehearse the whole environment and the simulation quite quickly and quite rapidly. So what I can now do is show you the other thing that we've got, which is the mission planning tool. Trying to find my mouse pointer, it's such a huge display. Like. So this is a tool called Neptus. It's designed by the University of Porto, and it's used for mission planning and also replaying missions after you run autonomous mission with underwater work. But they also have options, I think, for drones and for surface vehicles. So it's generally if you want to do these map-based mission planning stuff. So our colleagues
integrated with ROS.
no, it's not. They have their own system called Dune, which runs on their robots, which is also developed at Porto. But they have a communication bridge called IMC. It's inter-module communication, and we have a translator between IMC and ROS, which is there. So we can use that, and we can plan a mission in Neptune. Let me find the robot on it. I had it done before. Oh, I'm sorry. It has a few bugs because if the actual robot is also in the same network, then it tends to get confused which is the simulator one and which is the real one. But right now, we have it set at ASCO. This is the island near Stockholm, where we have. And this is a robot. So we have also created fake sensors in there, like a fake GPS, a fake IMU, all of that. So the feedback that you get from the localization, it actually is sent out into the messages that is published by the actual robot, and then that comes out in the Neptus interface. So this is what we also see when we actually run a mission. So we can rehearse the full mission from this scenario. So now I can actually try an example. So now I think I can show you a waypoint mission here. So here you can see 4 waypoints, and if I send a mission now to the robot, it should be able to run it. Fingers crossed. If it doesn't work, I can run it again, but let's see. So I'm sending the plan, and yeah, so now it's starting. It's trying to do the mission in the Stonefish simulator. We've also got some additional software to do some replanning, but it doesn't always work, and I have stopped it for the time being. But I can also start it now. It doesn't hurt. If I can find my cursor.
So the way you typically generate missions is to place the waypoints, and then you have
yes.
sort of an interpolation of the waypoints in time.
Exactly. So we have a mission refinement subtree. So it runs with behavior trees. So that's the AI that runs on it in that sense. One second, let me. I'm really sorry about this display thing because I cannot. There I am. Good. Because now you can't see what's happening, right? There we go. And so that you can see what the robot is doing, and on the other side you can see the mission. So if you see here, now you can see that it displays it up and down. So we have a behavior tree that refines the waypoints, but we also have a path planner which doesn't work right now so well, which to create a spline between the different waypoints, but that hasn't, that's part of work in progress. So the systems that are on it right now, so yesterday we did, except for finding the car, we did the rest of the mission out there next to the pier. We ran 3 waypoints with the same interface, with the actual robot, not with the simulator. But it was the same thing, and everything worked very smoothly in that sense. So for localization, we use the GPS in the beginning to get a fix, so we know where the robot is. And then after that, we use a Doppler velocity logger. It's an acoustic sensor which tracks the, which uses 3 heads of a single beam of acoustic waves. And it tracks the velocity with respect to the bottom of the seafloor. And with that, you integrate how fast you're going and find how far you've gone. And you have a compass to tell you what direction you're going in. So this strategy is called dead reckoning. The main reason we do that is because once you're under the water, you don't get any GPS signals, and you have to really rely on a lot of other instruments in order to get good localization. And that was the most challenging part, because otherwise, if you were on the surface, it's very easy to do this kind of mission, because you know exactly where you are all the time, so it's just a question of controlling it to go to those points. What we found very useful in this environment was that we could test all the pieces of the puzzle a lot of times, and we could screw up as many times as we wanted, because we don't actually have to go out and waste time when it happens. Like if you make a mistake, you can change one line of code, we run it again. And, we were able to tune especially the logic of the behavior tree. We also have emergency actions which we tested here. For example, in order to test if it goes too close to the bottom or if it hits an obstacle or something of that sort, we have a variable buoyancy subsystem inside the robot which allows it to pump in and out water to change the depth when it goes up and down statically. So in case of emergencies, we have a way of, when it realizes it's too close to the bottom or beyond the safety limit, it automatically starts going up. And that's also integrated in this, and we get messages actually. If it's close to the bottom, it says error, and it happened yesterday that it actually performed an emergency, and it continues once it's safe again to move on the mission. So these were some of the things that we've done. And here it's also got, now the mission is complete, it's done, its mission. And I'm thinking what else is interesting for you to know in that sense.
Yeah, I think it's a very nice presentation.
Thanks. And in case you're further interested in using any of these tools, we have, I think all of it is now published and it's open source, so I think we can share the links with you if you're interested in using it. As far as I know, the Stonefish environment is mostly for underwater stuff. It started off for underwater computer vision because there was a group in Spain who were developing it, especially one guy who's a researcher there, he was doing it there. And then we kind of retrofitted it for also a little more stuff like mission planning and mission execution and trials.
Stonefish is not directly with the Neptunus?
No, there are 2 different systems. So Stonefish was from Girona. They're the ones who first developed it and then we modified it. And Neptunus is from Porto. And they use it. It's a very powerful tool. It has a lot of different things. Like we're using very basic parts of it. We're only using the mission planning interface because you can also replay the missions that you've run. You can store a lot of data in it. The only problem with Neptunus is that it works very well with its own environment because there's Neptunus and they have their own pipeline for work. If you want to integrate it with the ROS, there's a limited amount of things we can do because we can only translate some messages from Neptunus to ROS, and we're using the ROS functionality more than the Neptunus functionality. We're only using it for mission planning at the moment, but there's always scope for expanding it and stuff like that. So, yeah, that's the main thing, kind of. Anything I missed?
No, that's fine. We could complement that also. The Neptunus software is also developed for these heterogeneous groups of autonomous vehicles. So going from with underwater drones, as we are doing here, to surface drones, to air, so flying, so collaborating in groups with all these different vehicles. So it's actually for that purpose that they have, and they are doing a lot of stuff with combinations with different research teams that are coming in and testing flying drones. I mean, these wing planes that you have had here also, I mean, that's similar as what they're doing there, and then they are sending these between, for example, underwater vehicles to share data. And so,
It's very powerful.
yeah, I mean, that could be something that we can also use for interacting between different types of vehicles.
Yeah,
One
one last thing which I forgot was we also have a web interface which kind of talks to all of the pieces in some way. Especially those of you who are familiar with using ROS, you know that you have to call a lot of different nodes from a lot of different places. So this is a nice way of putting it all in one place. So you can call everything by just clicking a button. We have all the nodes in one place, and you can also debug quite easily, like it already says something crashed, for example. So we use this a lot, and this is exactly also what we use with the actual robot. We have a newer version of this interface, but that's not yet integrated with the simulator. So I don't have it here right now. But we can command, for example, the different actuators right from here, so that we can test something on the robot to make sure everything is working, and we can also do the same on the simulator. Along with that, we can get some feedback, some basic stuff like how deep is there some emergencies, and most importantly, this line here, it's the leak sensor feedback. So if there's a leak or if it's sinking, then you know already very soon, and we've used that a lot, especially in the summer too. Yeah, that's the last piece of the puzzle. And now we also have a keyboard teleop kind of thing which we also use, but that's not in this interface. The new interface has some new functionality. You can also see the feed from the cameras and sensors and stuff like that.